Hello everyone, welcome to another video. Now in this video we are going to look at order agnostic binary search. Now what is order agnostic binary search exactly? So before going into that, let's go into what binary search is. Okay, now for those of you who know what binary search is, you can directly jump to the timestamp of order agnostic binary search. Okay, it is no big deal, it is not very different from binary search. Okay, so first let's get into the binary search and then we'll jump into the order agnostic binary search. So what is binary search? So as we know, it's a searching algorithm, right? But for a binary search, there should be one condition that should always be followed. That is, the array should always be sorted. It can be either ascending or descending. Okay, now what does this mean? Like, the array should be only in ascending order. Repetition is allowed, so it doesn't matter. Okay, or you can have like 5 4 3 2 1 or 5 5 4 3 2 2. Okay, this is allowed. So this is the only requirement that it needs to be followed when you're working with binary search. Okay, but how does it exactly work? So let's take an array 1 2 3 4 5 6 and 7. Okay, so for this, what we'll have is, we will have two pointers. One will be pointing at the starting of our array, another will be pointing at the ending of our array, and we will be given a target that we need to search. Let's say in this case we will search for 6. Okay, so now what will happen is, we will find the middle element of this. Okay, so how are we going to find that? Now there are two ways, but one of the way is pretty less optimal than the other. Okay, so first method is that you start plus end divided by 2. This is one of the method. Okay, where you take starting index, then you take the ending index and you divide it by 2, you get the middle index. Okay, the other method is that start plus end minus start divided by 2. Okay, now why is this method less optimal and this method is more optimal? Because there might occur some cases when, while using this particular method, you may run out of memory or array index out of bound. You may encounter those issues. Okay, so in those cases, like if you have very less number of elements in your array, then it is fine, you can use this. But to be on a safer side, this is always preferred. Okay, so in this case, our start is 0, our end is 0 1 2 3 4 5 6. Okay, so 6 plus end is what? Start is 0 plus end is 6 minus 0 divided by 2, that is 3. So 0 1 2 3. So our middle element is this one. Okay, after this sorry about my throat. Our middle element is this. After this, we will compare our target with middle element. If our middle element, that is array at middle, if it is equal to our target, okay, then we have found our target. We can either return true, or we can return the index of that element. Okay, it's up to you, whatever you want to return. Okay, else if we will check, else if our element at middle index, if it is less than target, that means this value is less than what we have to find. That means on the left part we will not find that element, because on the left of this we have smaller elements than this, and if this is smaller than our target, then elements before these this index are also going to be smaller than this. So this becomes a waste for us. this whole area. Okay, so what we'll do is we will take our start and we will assign it to mid plus 1. That means our start will come here. Why not mid? Why not mid? Because we have already seen this mid. We don't need to see this as well. These all elements are waste of time for us. Okay, so our start becomes this. Okay, this is our condition. And else, if a of middle is greater than target, then same logic. If like all the elements before this are obviously greater than the target. Okay, that means if we had our target 2 and we found this 4, so 4 is greater than 2, that means the elements, all the elements after this 4 are also going to be greater than 4. So this whole element, this whole area, it becomes it becomes a waste for us, right? So the same thing happens, and will become mid minus 1. Okay, so right now start is here. So again, start is at what's 0, 1, 2, 3, 4th index, and end is at 6. Okay, let me write it here. Our target is 6. Okay, so yeah, so now our mid is equal to start, sorry, not 5, it is 4. Start plus end minus start by 2. 4 plus 2 by 2. 4 plus 1, that is equals to 5. Now our 5th index, 0, 1, 2, 3, 4, 5. This is our mid. We will check if array of mid is equals to target. Yes, then we will return true or this index. Okay, so this is really that simple, and the same logic can be applied to the array if it is descending. Now I will leave that logic up to you. You try it yourself. Okay, it's really simple. All you have to take care is about this else if conditions. Okay, you will you will understand how to solve these if you go through these. Okay, just try to do it by yourself. It is really very simple. Okay, so now for those of you who don't know what is order agnostic binary search, it is really simple. It is same as the binary search, but the only difference is that order agnostic binary search does not see whether you have an ascending array or a descending array. That means in one simple algorithm only, you check for both these conditions. Okay, you don't have to write a different logic for ascending and for different logic for descending. Okay, both the logics are covered in one single algorithm. Okay, in that only one condition is different. We check how we check first, like what is the array given to us, is it ascending? Is it ascending? If it is ascending, then we follow that path. If it is not, then we follow a different path. Okay, it is really that simple. How do we check this ascending? Okay, we will compare our first array at starting index and array at ending index. If this is less than array of end, okay, then it is ascending. If array of start is greater than array of end, that means it is descending. And if it is let's say if it is equal, then it doesn't matter. If it is equal, then it doesn't matter, like whatever route you can follow. So for that we will simply write it here only, okay, to cover this scenario. Otherwise you can if you don't want to do this here, you can do like if array of start is equal to array of end, that means all the elements are same. Okay, that means you can return any value, it's fine. Okay, but in case if you want to find like the first index or first occurring index, that is a different scenario, we will cover it later. Okay, so that's it. Like we have completed like whatever the theoretical part was. Okay, so I hope you understood this. Now we will jump to the coding part. Okay, and I will not be coding the simple binary search, I will be coding order agnostic binary search. Okay, so how does that work? Okay, so first let us write like what is order agnostic binary search. Okay, order agnostic binary search is when you are not given if the array is ascending or descending. Okay, so now first thing that we need is the size. Okay, so let me take the size here. Okay, and let me write this here as well for readability. Enter the size. Okay, after that we need to create our array. Okay, array equals to new int, this is going to be of size n. Okay, now we need to read this array as well. For int I equals to 0, I less than n, I plus plus, array of I, that is equals to say dot next int. Okay, our array is ready. Now we also need to find our target. Okay, so we'll write enter target. Okay, so our let's say target, that is equals to sa dot next int. Now all the things that we need are ready. Okay, now in this question I will be only returning the boolean value, whether we have found the value in our array or not. It is up to you if you want to return the index. Okay, it's just a minor change, you can work on it. Okay, so first thing is that what are we going to okay, yeah, so our final boolean result is going to what it will give us. Let's say I will create a function order agnostic binary search. In this function I will pass two arguments. Okay, one is array and another is our target, and at the end I will simply print the result. Okay, now let me create this function. So public, and it is going to be static first thing, and this is going to return boolean, and the name of the function. Let me just copy this and paste this here. We need two things. First is our array and second is our target. Okay, now I think, is it fine? Yeah, that is better, I think. Okay, so how are we going to follow this? So first thing, we need two pointers. One is start, that will be equal to 0. Another is end, that will be equals to a dot length minus 1. Okay, now we need one more thing, that is we need to check if our given array is ascending or descending. For that, what I will do is I will check is ascending. Okay, how I will check? That is equals to if my array of start is less than equals to array of end, then it is ascending, otherwise it is not ascending. That means if this is smaller, a of start is less than or equal to a of end, it will return true. Okay, otherwise it will assign false to my variable. Now as I said, we will have a while loop while start is less than equals to end. Okay, now here what we'll check, first thing that we need is our midpoint. Okay, how are we going to find that? Start plus end minus start by 2. Okay, after this we will check if our array at mid index mid, if that is equals to target, okay, we will simply return true. Else we need to check now first thing, okay, else we need first thing is that if is ascending, else if this is ascending, then what are we going to do? We will check if our mid is less than target, okay. If our mid is less than target, then what will happen is start equals to mid plus 1, else end equals to mid minus 1. If it is not ascending, okay, then what will happen? This all thing will reverse, okay. That means if a of mid is less than target, okay, that means let me show you here. Let's say 7 6 5 4 3 2 1, okay. Now we need to find target equals to 6, okay, and our mid is this. If our mid is less than target, okay, this is our start, this is our end. If our mid is less than target, that means our end will be mid minus 1, okay. Our end will come here, that is mid minus 1. So this will become end equals to mid minus 1, else start will become mid plus 1, okay. It is that simple. And after all this, if after completing the while loop, if we do not encounter any value where a of mid is equals to target, that means the value is not available in the array. That means we will have to return false, okay. So our code is done as well. Let's do a dry run on this, okay. So let me run this, enter the size. So what is the size here? 1 2 7, okay. Let me write that 7. Okay, I did not write any value for that, right? Okay, so let me enter the values for the array. 1 2 3 4 5 6 7, okay. Now what is our target? 6. So let me write that. So it is present in that array, right? So let me try to reverse run this, like in the descending order, okay. Same thing, we have the same size 7, but this time it is in descending order. That means 7 6 5 4 3 2 1, okay. Now what was our target? 6, okay. So this is also true, okay. So it is really that simple, and you just need to understand like when to use what kind of when to move your start and end pointers where, okay. So yeah, that's it for this video. And the reason why I covered this binary search is that because going forward, when we are trying to do more lead code problems, this binary search is going to be very helpful for us, because the binary search is useful when you are very useful when you are working with 2D matrix, like 2D array, okay. So when you want to find values and when you want to find different particular value in the 2D matrix, okay. So that is at that point going through the whole matrix, that would take n square of time, okay. So that is not optimal. So for that we will be using binary search algorithm, okay. The next video that I'll be uploading is going to be based on binary search, okay. So I will recommend that you watch this before you move on, okay. And in the next video that I will be uploading, I will provide the link to this video as well, okay. So yeah, that's it for this video. I hope you liked this and you understood what binary search and order agnostic binary search is, okay. So thank you for watching. Let me know if you have any other problem, doubts or queries for me to solve from any other platform, okay. So yeah, I'll see you in the next one. Till then, keep coding.